discuss some good problems on rotational motion. Okay, and the first question is like this: a string is wrapped around a cylinder of mass m and radius r. The string is pulled vertically up to prevent the center of mass from falling as the cylinder unwinds the string. The tension in the string is okay. तो क्वेश्चन जो आपको दिया गया है कुछ इस तरीके से लिया आपने एक यहाँ पे सिलेंडर लिया या एक एंगुलर सिलेंडर स्ट्रिंग इज रैप आपने एक स्ट्रिंग को इस तरीके से इसके रैप किया होगा लाइट स्ट्रिंग है और रैप करके आपने you have connected this block from this point. Okay, now the cylinder is released from the wrist. Mass of the cylinder is m, radius r. Now what will happen if you release this cylinder from this point? Due to weight it will start to move in downward direction, and due to this string it will start to rotate. Now what will happen? The acceleration of center of mass in this case will be like a, and due to t there will be some torque, and torque about center is alpha. Okay, now see here, if we write t is this, now all these three quantities t, alpha and a are unknown to us. We have to find them. Now think for center of mass of the cylinder, net force is mg minus t. Net force for center of mass, net force for a rigid body will be like net force equal to m into ACM. Center of mass acceleration is a, then equation for center of mass is like mg minus t equal to ma, net force equal to m. Now torque about center will be reduced by t, tension, and perpendicular distance of tension from the center of mass is r. The total torque produced by the tension about center will be t into r. Now for torque about center we can write torque equal to I alpha about center, torque equal to I alpha, and I about center is mr square by 2 alpha. Okay, now equation is like the t is equal to mr alpha by 2. This is the second equation, this is the first equation. Now we have total 3 unknowns. We have to find relation between a and alpha. Now see, if you see this discussion, see here, for cylinder there are two acceleration. First, acceleration of center of mass, and second, angular acceleration alpha. If you consider translatory motion, each point has similar acceleration in downward direction, and if you consider rotational motion about center of mass, you will say this point have downward acceleration r alpha, this point have upward acceleration r alpha. Now if we add them, we will get like this. This point has downward acceleration a and upward acceleration r alpha, and this is connected to rope also. Acceleration of rope will be 0 because it is at rest. That means a and r alpha must be equal so that there is no slipping. That means a is equal to r alpha is your required and third equation. Okay, now if we solve all these equations, we'll get the first equation is mg minus t equal to ma. Second equation, taking torque about axis passing through center of a spool and perpendicular to it, torque equal to alpha. Remember, you can apply torque equal to I alpha for combined motion only about the axis passing through center of mass. About axis passing through center of mass, torque equal to I alpha. I is mr square by 2 and t is equal to ma by 2. My equation is mg minus t equal to ma, and if we solve the value of a, we'll get a equal to 2g by 3 and tension equal to mg by 3. Now this point of this discussion is torque equal to force into perpendicular distance, where r is the distance measured from the axis of rotation to where the linear force is applied, and theta is the angle in f and r. In our case, force is perpendicular to the distance. Now take one more question. This question is for to revise concept of parallel axis theorem, perpendicular axis theorem. Okay, now see, a thin rod of length 4L and mass 4m is bent at shown in figure. What is the moment of inertia about an axis passing through point O? आपको ये axis लिया है, this axis, this red line is perpendicular to the plane of your screen, okay, and passing through point O. Now, there is one structure of shape of L, one more structure of shape of L, okay. Now see, if I have to find moment of inertia of this rod, okay. Let's say moment of inertia of this rod is about this point is I1. Moment of inertia of this rod about this end is I2. Moment of inertia of this rod about this point is I3, and about of this rod about this point is I4. Clear? Then what is the total moment of inertia? Total sum आपसे पूछा गया था total. You will say total moment of inertia is I1 plus I2 plus I3 plus I4. Done. Now by symmetry, you will say moment of inertia of I1 and I2 must be same about this axis, because this axis is passing through the end of the rod. I1 equal to I2. You can write 2I1, 2I1, and similarly I3 and I4 have similar moment of inertia about this line. You will say 2I3. Okay. Now it's our responsibility to find I1 and I3. I1 will be ml square by 3. Okay. Mass of one rod will be m, length is L, ml square by 3. And what will be the value of I3? Now see, you have to find moment of inertia about this axis. Okay. And this is your center of mass. If we know the moment of inertia about center of mass of the body, we can transfer same knowledge to another line passing through the any other point in the space, but parallel to the axis passing through center. These two lines are parallel. Okay. And they must have some distance. Let's say distance is x. Then you will say I3 will be like ICM plus mx square. Now, what will be the value of ICM? Moment of inertia of body about axis to center of mass is like ml square by 12, and x, this length is L, this length is L by 2. X by Pythagoras theorem will be like L square plus L square by 4 and 5L square by 4. Clear? So M into 5L square by 4. Now put value of I1 here, put value of I3, you can find the total amount of inertia. Okay. See here, I1, I2, I3, I4, and moment of inertia of one rod about axis passing through end is ml square by 3. And second, that is further rod is ICM plus mx square, and x equal to L by L square plus L square by 4. Okay. Now see, we are saying a disk is freely rotating with an angular speed omega on a smooth horizontal plane. There is one disk, just like this, omega is rotating about center of mass. Okay. Now suddenly you is this rotating disk, you pin a point there. You pin this disk at this point. Now what will happen? This disk will rotate about this point. Okay. See here, like this. This is okay, like this. This will start to rotate about this point. Okay. Now, if you pin about this point, you will say moment of inertia, whatever be the jerk is developed in this question, that jerk will pass through point P. Moment of inertia about P, angular momentum about P initially was simple mr square. If this is this, that will be like mr square by 2 into omega. And after rotation, Lp prime is equal to mr square by 2 plus by parallel axis theorem, moment of inertia about this point is mr square by 2 ICM plus mr square into omega prime. Then answer will be like mr square by 2, 3 mr square by 2 omega prime. Mr square by 2 is cancelled, and omega prime is equal to omega by 3. Okay. This discussion is here. They are saying, see, again, I'm repeating it. This is your disk, and this is rotating about your center of mass. Okay. About any point, you will say moment of inertia same, that is ICM omega. Okay, because there is no translatory motion. Now, you what are you doing? You are pin up this disk at this point. You have fixed this disk at this point. Now, what will happen? Due to angular momentum, this will start to rotate about this point like this. Okay, it will try, and the center of mass of the disk will follow circular motion about this point. Now you have to find relation between this and this omega. This omega prime is of center of mass about this fixed point. Now, what is conserved in this case? Because a pin up this this at this point, whatever with the force is there, that point force will pass through this point. That means torque about this point will be 0, and angular momentum at this point will be, let's say, this point is A. Torque about A is 0, and angular momentum about A is constant. Now, angular momentum about A initial was simple mr square by 2 into omega, and after pin up about center is mr square by 2, and applying parallel access theorem, you will get moment of inertia at this point about this point will be 3 mr square by 2. And answer is 3 mr square by 2 into omega prime. Okay, you can find omega prime in this case. Any doubt? Ayush, which option? C? Okay. Now, next question. This question is based basically on a combined motion, that one body is following translatory motion, pulleys are following rotational motion, and you have to find the acceleration of blocks. Okay. Now, we can approach this question by two concepts. See, each pulley has moment of inertia I, a radius r, and m is released, small m. Now, if you release this body from this point, let's say capital M is heavy, it will move in downward direction. Small m, by constraint, it will move in upward direction. Let's say it gains speed of v, and this disk will gain angular speed of omega, and this will gain a speed of omega. Now, let's say this is the initial position. Okay, both blocks are at same position 0. Now, after falling distance, let's say y, it will gain distance of y. Now, can we apply conservation of mechanical energy in this case? Obviously, we can apply conservation of mechanical energy because there is no slipping at any contact point. If there is friction, it cannot do any work. Work done by friction in this scenario is 0, and you can freely apply conservation of mechanical energy. Now, say initially, small block is at rest, large block is at rest, pulley is at rest, second pulley is at rest, and both blocks are at 0 potential level. Okay. Now, after some time, larger block will gain a speed of v, half mv square kinetic energy. A smaller block will gain a speed of v, half mv square kinetic energy. For pulleys, kinetic energy will be like half I omega square, because both pulleys are identical. They will gain same angular speed, not always, but in this case, omega is equal to v bar, radius is same. They gain same angular speed 2 times. Now, capital M will fall downward. It will have minus mgy potential energy, and small m will go upward by the same distance mgy. Okay. Now, can you write it as mgy minus mgy is equal to half m plus m into v square, and half I into omega v square by r square into 2. Okay. Now, we can say this value in this scenario, we can take v square common, m plus m by 2. Okay. I divided by r square, and mg minus mg into y. What will be the value of v square? V square will be like m minus m into gy, m minus m into gy divided by m plus m by 2 plus I by r square. Let's say this whole term is a constant value. Okay, this. Okay, v square equal to some c into y. Differentiate this term with respect to the y because velocity is changing with respect to this distance also. Take d by dy of v square, d by dy of cy is c, and d by dy of v square will be like 2v dv by dy equal to c, and v dy by dy is the acceleration. I think they are asking about the acceleration of the blocks. The a is equal to some simple c by 2, and c in our case is m minus m into g divided by m plus m by 2 plus I by r square. This is your acceleration. Okay. Now see, this is the answer, and I have solved this discussion by concept of mechanical energy because there is no work done by friction. Mechanical energy will remain conserved, and the solution is very beautiful. Another solution. Let's say m is going downward. You can write the equation of force, that is mg minus t3 is equal to ma. This string is going upward, T1 minus mg equal to ma. Think here tension is T3, here tension is T2, here tension is T2, and here tension is T1. Why a string has different tension? Because these pulleys are not ideal pulleys. These pulleys are rotating because this pulley is rotating. Okay, see here, this pulley is rotating about this point. Definitely T3 must be greater than T2. Okay, and this pulley is rotating in this sense. The T2 must be greater than T1. The T3 is greater than T2 is greater than T1. Okay. Now T1 minus mg equal to ma, clear. Mg minus T3 equal to ma, clear. A equal to r alpha is by pure rolling, pure slipping. There is no slipping at any contact point. For pulley, we can write torque equal to I alpha. We can get two equations for torque. And by discussion, we can solve the acceleration of the system is m minus m into g divided by m plus m into 2I by r square. Okay. Acceleration is like this. C by 2, 1 by 2 is also done. Now, one more interesting question. Any doubt in this discussion? Any student? Any doubt? See here, the system of identical cylinders and plates is shown figure. All the cylinder identical, there is no slipping at any contact. When they say there is no slipping at any contact point, it has some meaning. They're saying there's no slipping at any contact point. The velocity of the lower and upper end are v and 2v. Okay. Now, see for above cylinder, okay, and for lower cylinder. Okay. For lower above middle tank, speed is v in left direction. For above plank, speed is 2v in right direction. Yeah? Now see, let's say this cylinder center has speed v1. It is rotating with some angular speed omega. Okay. Now think about this cylinder. Its top point has speed of v1 plus r omega because v1 and v1 is forward for this point, and r omega is also in forward direction. The top point of the cylinder has a speed of v1 plus r omega, v1 due to translativity, r omega forward due to rotation motion. Now, the point which is contact with this point is on a sphere. So this point is on plane. It has speed of 2v. Now, if you are saying there is no slipping, there is no slipping. No slipping means both points must have similar tangential velocity. Then answer will be like v1 plus r omega equal to 2v. And now, about lowermost point. Lowermost point speed is backward direction. See, forward speed is v1 minus r omega and backward speed v. If there is no slipping, that means v1 minus r omega equal to minus v. Simple. Now, can you tell me the speed, angular speed in this scenario? Yes, we subtract these two. we will get 2r omega is equal to 3v and omega equal to 3v by 2r. This is the angular speed of upper cylinder. Upper cylinder is rotating with this omega. Okay. Now come to the point. They are asking the speed of lower most point. See here, because upper plank is moving in this direction. Okay. This point is speed of v in this direction. Let's say center is moving towards this v2, and now angular speed of this part is omega prime. Now see, for cylinder, topmost point has speed of v2 plus r omega prime. How can I say v2 plus r omega prime? Because due to translatory motion, it is shifting in left direction, and because you are considering omega prime is like this, omega prime is towards left side. Okay, and omega prime will be v2 plus r omega prime will be like v. Okay. Now for lowermost point, v2 is in forward direction and r omega prime in backward direction. It is in contact with lowermost point, that is ground. Velocity of the ground is 0. That is v2 minus r omega prime is 0. And they are saying v2 plus r omega prime is v. Okay. Now we have to find, we don't have interest in v2. They are not asking about it. v2 minus r omega prime equal to 0 and v2 plus r omega prime equal to v. If you add them, you will get 2v2, sorry, if you subtract them, okay, you will get 2r omega prime equal to v and omega prime equal to v by 2r. Now they are asking about two things. First, they are asking about the angular speed of above cylinder, that is 3v by 2r, and angular speed of lower cylinder, that is v by 2r. What is the ratio of these two angular speed, omega by omega prime? Tell me. Omega prime is 3v by 2r and omega prime is v by 2r. Cancel and ratio is 3:1. Okay. Similarly, it's a very fine solution. So they are discussing in terms of simply because omega of any body is relative velocity divided by distance. Okay. Now see, for above sphere, lowermost point is moving towards v, left side, and upper point is moving towards right 2v. Then omega will be right relative velocity v in left, 2v in right. That means relative velocity is 3v divided by 2r. You can write it easily. Omega equal to 3v by 2r. And for lowermost point, this point is zero velocity and this point is v. The lowermost point omega equal to v divided by 2r. Okay. Omega is simple relative velocity, v relative along tangent divided by distance is the basic concept of angular speed. Okay. Now one more question. A uniform rod along the axis. Any doubt? Any doubt? See here. They're showing a uniform rod along x-axis. This is a uniform rod lying along x-axis. Okay. The locus of all the points on xy plane. You have to find the locus of the points about which the moment of inertia is same as that about O. Okay. Now see, moment of inertia about center of mass is IC. Okay. Moment of inertia about O is IO. And if I choose one point at distance, let's say this distance x, this distance is x, one more point at distance 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 x. Basically, I am finding some points having equal distance from center of mass. Okay. Now, what will happen? We will get a family of points having same moment of inertia about, that is about O. Okay. It will have same moment of inertia because about this point moment of inertia will be like ICM plus mx square. About this point ICM plus mx square. About this point ICM plus. These points are at x distance from the center of mass. Can you tell me moment of inertia having similar value must lie on circle. The locus of all these points having similar moment of inertia must be a circle. Okay. Now Next, there is a uniform rod of mass m length L placed on a smooth along surface y-axis rest as shown figure. The impulsive force applied at some small time delta t. Impulsive, it is understood it was applied for very small time. The x-coordinate of the end A of the rod when the rod becomes parallel to the x-axis. Initially, the coordinate of center of mass is 0, 0. Now see here, I will explain the discussion. If you hit the rod, this rod is lying table, and you make a sharp impulse, like you hit by some rod. Okay, you hit it. When you apply this force, you provide some force for very small interval FTT. Now they are saying due to this hit, this rod will gain a velocity in forward direction. This is the translatory motion. And due to this rod is hit at the end, you will gain some angular speed. If I apply force at this point, you will not gain any omega, because you have applied at this end. You are applying some torque about center. You will gain some angular momentum about center. Angular momentum about center is like omega. You will gain some omega. Now omega and v is there. Then F delta T and F dt is equal to MVCM, or VCM is equal to V. Now F is applied at some distance. FL by 2. This term is a torque. This term is torque, and torque delta T is equal to change in angular momentum. Initially rod was at rest, L final mass initial 0, and after hitting, the rod is rotating over center of mass about ml square by 2 into omega. Okay. Now, if I remove F delta T from these two equations, you will get omega equal to 6V by L. Omega is 6 times of V divided by L. S equal to UT. Now, if I say, what will be the displacement of center of mass in this case? Center of mass in this case, if you're rotating by 90 degree, on 90 degree, you will say 90 degree equal to omega into T. 90 degree you cannot write, you will write pi by 2 is equal to omega into T. And this period, center of mass will shift by S equal to V into T. Okay. Now S is equal to omega L by 6 into T and pi by 2. Can you remove omega T from these 2 points? Then pi by 2 is equal to L by 6 into, see here, omega into T. S is equal to omega into T is like pi by 2 into L by 6. And S is equal to pi L by 12. The displacement of the center mass, if you hit this, center mass will be like this here. Now they're asking about the coordinate of A. Okay, they're asking about the coordinate of A. A will move in forward direction by distance of pi L by 12. Okay. And it will rotate by this pi L by 12 will be a shift, and सेंटर के रिस्पेक्ट में आपका L by 2 और ऐड होगा, तो pi L by 12 plus L by 2 and y coordinate is 0. Clear? So basically, question is based on two concepts. But due to this linear impulse, you will get MVCM, and due to torque delta T, you will gain IC omega. Now, if I divide this, delta T will be removed, and F torque is equal to F into X, point of application distance from the center. F is equal to MVCM divided by IC omega. F can also be removed, then X is equal to, or VCM by omega is equal to I divided by mx. I in this scenario is ml square by 12, and mx, x is at L by 2, cancel, and answer will be L by 6. Okay. Now, one more question is also interesting question. Read this. A cord is wrapped on a pulley of mass m. One end of the cord, a block of mass m is connected in the shown figure. Now, you are doing two things. First, you are applying a force of 2 mg, and second, you connected a block of mass 2 mg. I think these two conditions same. No. These two conditions different because in this scenario, you have decided the tension is equal to 2 mg. But in this scenario, tension definitely will be less than equal to 2 mg, less than in comparison to mg because 2 mg is falling and 2 mg will fall when tension less than 2 mg. So in this scenario, tension is equal to 2 mg. In this scenario, tension is less than 2 mg. Done? Now they want to ask acceleration of m in these both cases. This is moving upward. This is moving upward. This is a1. This is a2. Okay. Now see here. You are applying tension 2 mg here. Here tension is T. Here upward force is T and is moving upward direction by A1. Okay. Now see here. For pulley, 2 mg into R minus T into R. This is net torque on the pulley is equal to I alpha mr square by 2 into alpha. And T minus mg is equal to m R alpha. Basically, A is equal to R alpha. Okay. Now, we have interest in this 2 mg minus T. You can solve it like this. 2 mg minus T equal to mr alpha by 2. Then, and T minus mg equal to mr alpha. Now add them. T will be cancelled. 2 mg minus mg equal to mg. And mg equal to 3 mr alpha by 2. Basically, R alpha equal to 2g by 3. Then, and R alpha is equal to acceleration of the block. In first scenario, acceleration A1 is equal to 2g by 3. Okay, now see this question. Acceleration will be like 2g by 3r. Okay, A equal to 2g by 3. Okay, some calculation mistake is there. A is equal to 2g by 3. In second scenario, you will say tension in this part is T2 and this part is T1. T2 minus T1 into R equal to I alpha. And this is for pulley. T1 minus mg is equal to, because mg is moving in upward direction, T1 minus mg equal to MAB. And 2 mg minus T2 equal to M because this block is moving in downward direction. Okay. 2 mg minus T equal to 2 MAB, AB equal to RAB, and acceleration in this scenario will be like 2g by 7. In first scenario, acceleration equal to 2g by 3. Some calculation mistake is there. AB equal to 2g by 7. So A is greater than AB. In first case, acceleration is greater than acceleration B. Now you can think in terms of one more thing. You will say, okay, leave it. This is the right frame. Now, there are two uniform boards tied together with the help of a string are balanced on the surface shown figure. The coefficient static friction between the board and the surface is 0.5. The minimum value of theta for which this arrangement is possible. Okay, see here, there is a board. Okay, it is aligned like this, and it is tied with one string. The string is horizontal and force is like this T. And there is no need to make another blocks free body diagram or diagram because both are similar, symmetric. Now, force on this body is mg. Some normal action from this point because surface horizontal, normal action will be vertical. And this point, tell me, this point has a tendency because this is like this. This point has a tendency in this direction. You can assume friction in this scenario will be like this only. Okay. Now see one more thing. I'm saying this body is in equilibrium. That means normal action will be balanced by mg and tension will be balanced by friction only. Now, one interesting thing comes in our picture. See, this is mg and this is mg. Though it is normal action, but it's magnitude equal to mg. And this is friction and this is friction. Okay, because both. So in case of equilibrium, we will definitely have some force couples. Okay. Now, can you say what is the sense of rotation due to mg? Sense of rotation due to mg will be like this only, anti-clockwise, and sense of rotation due to friction that is clockwise. Now, due to force decouple is independent of choice of origin, torque are balanced, torque due to friction and torque due to mg are balanced. Torque due to mg into perpendicular distance between them. If this distance is L by 2 and this angle is theta, the perpendicular distance between them will be like L by 2 cos theta, then mg into force mg into L by 2 cos theta. And the perpendicular distance between friction and friction is like this. This is perpendicular distance. If this angle is theta, then this distance is L and this is L sine theta. Okay, and friction into L sine theta. Clear? L cancel. That means tan theta is equal to, tell me, mg divided by 2f. Okay, tan theta will be like mg by 2f. Done? Clear? Now, see here, tan theta is equal to mg by 2f. That means friction is equal to mg by 2 tan theta. You know very well friction must be less than or equal to mu n, and n is equal to mg. In our case, not always. Mg cancel. Mu must be greater than or equal to 1 by 2 tan theta. They are asking about the value of tan theta. The tan theta must be greater than 1 by 2 mu. Done. The value of mu is 0.5. So tan theta, 0.5 tan theta must be greater than 1. That means minimum angle is 45 degree. If angle is less than 45 degree, it will definitely slip. To be in equilibrium, this angle minimum should be 45. At 50, it will be in equilibrium. At 60, it will be in equilibrium. But at 30, 35, 39, it will not be in equilibrium. It will definitely slip. Okay. This is the discussion. Normal direction and 1 and 2. For rotational equilibrium, net torque must be 0. For translational equilibrium, net force must be 0. Okay. Now see, one more. For safe equilibrium, friction must be less than limiting friction. What is the value of limiting friction? That is mu n. In our case, normal direction is equal to mg. Now, a solid cylinder is placed on an inclined plane. It is found that the plane can be tipped at an angle theta before the cylinder starts to slide. When the cylinder turns on this side, the cylinder allowed to roll. It is found that the steepest angle at which the cylinder performs pure rolling is phi, and phi and tan theta ratio they are looking for. Now, see, they are saying this is an inclined plane. If we increase the angle, definitely body is not sliding but slipping. They're saying if body is in this cylinder is an inclined plane in equilibrium, then force down the incline force must be balanced by friction. Friction must be equal to mg sine theta. Mg sine theta. Limiting friction is less mu n, and n in our scenario is mg cos theta. That means tan theta equal to mu s. For rolling, function friction is equal to mg sine theta divided by 1 plus r square by k square, where r is the radius of gyration. If you put radius of gyration as, because they are a solid cylinder, then r square equal to k square equal to r square by 2. And this value will be like mg sine theta by 3. For pure rolling, mg sine theta by 3 is less than mu s mg cos theta. So for this discussion, tan phi is less than 3 mu s, and tan phi divided by tan theta equal to 3. Okay, clear? Next, the moment of inertia about this square plate ABCD of uniform thickness about an axis through the center of O perpendicular to the plane. They are saying what moment of inertia of the square plate. Now see here, solution. If you are considering a square, this line and this line, these are diagonals. Okay, these are diagonals, and moment of inertia about these lines. Let's say 1 and 2. Okay, 1 and 2. I1 and I2. I1 and I2 must be equal to IZ. I1 plus I2 equal to IZ. This is perpendicular system, but by symmetry, both terms are diagonals. I1 and I2 both are diagonals. This square plate has similar mass distribution about 1, and similar mass distribution about 2, then definitely by symmetry I1 is equal to I2 is equal to IZ by 2. Done. Now, next lines, they are saying this line is I3. This line is I3, this is I4. I3 and I4 are mutually perpendicular and passing through the center, and I3 plus I4 must be equal to IZ. Now, what comes in our mind? I3 plus I4 equal to IZ, and this body has similar distribution about 3 and similar distribution of 4. If distribution is same, you can say mass distribution is same, then moment of inertia must be same, then I3 equal to I4 equal to IZ by 2. Done. That means I1 is equal to I2 is equal to I3 is equal to I4. All moment of inertia are similar and equal to half of the moment of inertia about z-axis. Okay. Now think, if this is the disk case, you can say similar discussion will be there. 1, 2, 3, 4. Sorry, 1, 2, 3, 4. All have same moment of inertia because all lines are diameter. But this will not be the case in case of rectangle. In case of rectangle, everything you can apply perpendicular theorem, but symmetry is not there. We'll have to think in different terms. Any doubt? Now see here, horizontal is rotating about freely about vertical axis through its center, ring and disk, same inertia, now gently placed on disk. After some time, the two rotate with common angular velocity. Then some friction exists between the disk and ring. Definitely, due to friction. See, this is the case. A disk is rotating. This is a disk. Okay, rotating about the axis passing through center. Okay, this is your disk. Now see here, a ring having same mass and radius at the disk is placed here. Okay. This is your ring and this is this. It's placed here. Now gently place over this. Initially, because lower part is rotating and upper part is at rest, there must be some friction because upper part is rest and lower part has speed r omega. Due to this relative motion, there is slipping. This slipping, this friction will reduce the angular speed of disk and increase the angular speed of ring till they both have similar linear speed at contact point. Okay, I'm not saying that omega must be same. They must have similar linear speed at the contact point. Now see what they are writing solution. Initial angular momentum of the disk mr square by 2 for disk ring mr square. Now initially angular momentum was associated with only disk. Then we can apply simply I1 omega 1 plus I2 omega 2 is equal to I1 plus I2 into omega prime. Okay, this is the answer. You can find omega prime. If they want to know what is the loss in kinetic energy, just compare K initial and K final. You can find angular velocity. And if some energy is lost, you can say this energy is converted into heat only. Okay. Now, see here, a disk of circumference as it rests between. We'll pick some other question. See here. A thin rod of mass m in length is free to rotate about its upper end. When it is at rest, it receives an impulse at its lowest point, normal to this length. First, you have to visualize the problem. This is a rod. This is free to rotate about its upper end. That means it is fixed at this point. And if you're hit by some force, okay, let's see, apply some impulse. Impulse is basically force into time. This combined value is J. Okay. Now, what will be the angular momentum? Simple. Angular momentum, torque, angular impulse is J. That is, linear impulse. Linear impulse is J. So J into L is angular impulse, and that will give angular momentum to the rod, L final minus L initial. Initial angular momentum was 0, and L equal to J into L. They can ask about angular speed. Angular speed is simple. J, L is equal to ml square by 3 into omega is equal to J into L. You can find omega. You can find kinetic energy of the rod. You can find the linear speed of the midpoint. Linear speed of the midpoint will be like, because this point is rotating about this point at radius of L by 2, the linear speed of this point will be like V equal to L by 2 into omega. And you have already solved the value of omega in this case. Okay. Next. A 1 kg solid sphere rose without slipping on a rough horizontal surface influence of 7 Newton force. See here. It 1 kg solid sphere you have taken. You have applied some 7 Newton force at this point, at highest point. They are asking about what would be the frictional force. See, these questions, basically 3 questions are there: friction force direction, friction force magnitude, and acceleration of the sphere. Now see, if you're applying this force, you can say this body will move forward in forward with acceleration of center mass as A, will rotate about center mass with alpha, and friction. At this point, friction will be like this. Friction will be static because there is no slipping at this contact point. Friction may be 0. Friction may be forward. Friction may be backward. It will depends upon the answer. Okay. I am assuming that this friction is moving in backward direction. If my assumption is wrong, I will get negative value. If I am assuming in a forward direction and I am getting negative value, then friction will be in backward direction. Plus value confirms your answer, and negative value will say your assumption is wrong, friction is opposite action. That's it. You don't have to worry about where friction will work. Friction is static. This value will be solved by the equations only. By the help of equation, you can solve all the values. Now see here, in the horizontal direction, 7 minus F is equal to MA is one equation. Friction into R plus 7 into R is equal to I alpha, second equation. Because there is no slipping at this contact point, that means A is equal to R alpha. Okay. Now, you know how many unknowns are there? A, we don't know, alpha, we don't know, and friction. By solving these 3 equations, we solve the value of friction, A and alpha. These values are ready, and discussion friction is equal to 3 Newton. Okay. The point of the contact in the sphere and the surface slips to the left, so the friction acts towards the right. According to the sir, friction is acting towards right, and I am assuming friction acting is towards left. Okay. Now, whatever be the answer, you can solve it. It's simple. 7 minus F is equal to M, and 7 plus F is equal to I alpha divided by R, and alpha is equal to I bar. Okay. If you subtract them, you will get a value like 2F is equal to I by R square into A minus M. The friction is equal to 1 by 2 into I by R square minus M into A. Okay. Or if you want to know the value of friction, you can simply divide them. You can solve the value of friction. See here. 7 minus F divided by 7 plus F is equal to M into A divided by A I by R square. A cancel. M and moment of inertia. This body is solid sphere. Then I will be like 2 by 5 mr square. R square cancel. M cancel. This value is 5 by 2. Then 2 into 7 minus 2 into F is equal to 5 into 7 plus 5 into F. 14 minus 2F is equal to 35 plus 5F. This value is 7F, and 14 minus 31 is 14 minus 35 is minus 21, and friction equal to minus 2. Friction will act because I am assuming friction is acting in left direction and friction is negative. Then final answer you will say, sir, friction will act in forward direction and magnitude of friction is 3. Yeah? We have similar answer. Now see, a bucket of some part is there. They are saying this is a similar question. This I am giving you the diagram. A bucket of 21 kg is wrapped around. We have covered this question. This is mass M. This is your pulley. Mass of the cylinder is capital M. Radius is R. And this point is fixed at this point. Okay. like this. Okay, now I will release. This will move in backward direction. This will turn. You can solve this equation by mg minus t equal to ma, t into r equal to I alpha and a equal to r alpha, or by the concept of energy. Okay. Now, one more question is there. It's an interesting question. They are saying the solid cylinder of radius r equal to 0.1 mass 2 kg is placed such that it is in contact with the vertical horizontal surface. The coefficient of static friction is mu equal to 1 by 3 for both surfaces. Find the distance d from the center of cylinder, which of 40 newtons should be applied vertically so that just cylinder just start rotating in anti-clockwise direction. Time is less. I will explain you the free body diagram or diagram of the body. mg will be at the center in downward direction. You are applying friction, so a force F. Due to this force F, this ball will try to rotate in this direction. And due to rotation, you will have kinetic friction mu n2. N2 at this point is, you have to solve N2 and mu N2. And because body is rotating like this only, okay, this point has normal direction. And if this point is rotating like this point will go downward and friction will be in upward direction. You can solve the values of N1, N2 and all the things. Just they are asking about what is the distance so that it start rotating in anti-clockwise sense. Next, see this rod is fixed at this side and you are cutting the string at this point. If this is fixed at this point, this will rotate. Equation will be like mg minus n equal to ma. See here, mg minus n equal to ma for center of mass. And about center mass, we will have about this fixed point, we will talk mg into L by 2 as ml square by 3 into alpha. And simple, if this body is rotating like this, center mass will follow circular motion about this point, and center mass acceleration will be like A equal to L by 2 into alpha. This is the equation of kinematics, this is the equation of rotation, and this is the equation of second law for center of mass of the rigid body. Okay, all equations are here. Talk equal to mg into L by 2, alpha, A, all are there. Now, this uniform disk is applied like this, force F. Let's say they are saying you have to find acceleration of center of mass. Acceleration of center of mass, see here, in horizontal direction, because center of mass can move in this direction only. Acceleration of center of mass is like only net external force divided by total mass. Mass of the body is m, and external force in right direction only. There is no external force because friction is 0, F minus 0. Then acceleration will be F by m. No need to solve the question. Just answer is A equal to F by m. Okay. Next question. See here, they are saying this is also similar to the other question. A boy is pushing the ring of mass m2 kg 0.5 is shown in figure. The stick applies the rules without slipping. A equal to 0.3. The coefficient of friction between the ground and the ring is larger, and rolling always occurs. The coefficient of friction between the stick and the ring is P by 10. The value of P, just due to time constraint, see here, you are pushing the rod by this force F. Due to rotation, you are getting two frictions. One friction is at this point, and second friction from the ground. Because this body is not moving, you will say the net force applied by the rod is 2 Newton. This force is F square, F prime square. You have to solve the, due to time constraint. I will pick this equation in the next class. Or one more question is there. A horizontal circular platform is rotating. This mass speed as this. Each gun suddenly fire the ball horizontal perpendicular to the diameter in the opposite direction. After leaving the platform, the balls have horizontal speed 9 meters per second respect to the ground. The rotational speed of the platform in the radian per second before leaving the platform. You are saying that you have launched these two balls in this direction. Then by concept of conservation of angular momentum, 2 mvr is equal to I omega and omega is equal to 4 radian per second. One more question is there. Two identical disc rolls from this point, because it is falling by 30 meters. They are saying friction is sufficient, rolling without slipping. If there is no rolling, this is why there is no slipping without, there is no slipping at contact point, you will say work done by friction is 0 in both cases. And if body come roll from this point to this point, you will say at bottom loss of energy mgh is converted into gain in kinetic energy. Half mv2 square minus half, sorry, rotation is kinetic energy also there. You will say loss of an mgh is equal to gain in kinetic energy. Okay, and change in kinetic energy will be, kinetic energy will have two parts. One part is half mv square and second part is half ICM omega square, because this disk ICM is mr square by 2 and omega square equal to v square by r square, cancel. Kinetic energy will be like 3 by 4 mv square, then 3 by 4 m v2 square minus v1 square equal to mg delta h for first body, and 3 by 4 v2 square minus v1 square equal to mg delta h prime for second body. Both, if one body has fallen by 30 and second body has fallen by 27 centimeter. Okay. So lots of question we have covered in this discussion. I tried to cover more and more question, and in next class we will focus on some more interesting methods. जितना आप अच्छे क्वेश्चंस अटेम्प्ट करते जाएंगे उतना आपका एक लेवल बढ़ता जाता है. I tried, and आप भी एक सारे क्वेश्चंस को एक बार प्रॉपर्ली अटेम्प्ट करिए. Okay.